So this lesson talks about collecting like terms. So what I've got here on this paper is I've got 5 different examples of collecting like terms. In order to find out if they're like, it's kind of like taking inventory. So when I look at this problem, this first one, we're going to use example 1 here. When I look at this one, I see 8m minus 14m. So I kind of think of that as label something with an m. So I have 8 marshmallows and I want to subtract 14 marshmallows. So all it is it's a label on the product. So I don't have enough marshmallows to give 14 away or to take 14 from 8. So this goes back into my integer rule. So I do know that they're like because they're both marshmallows. I just now need to figure out what my answer is going to be. I have to keep my label because that's how I know what I'm talking about. So I keep my m, and then I need to do integer subtraction or addition. I know that there are 8 good guys and 14 bad guys, so I know I'm going to have a negative answer because I'm going to be in the hole the amount of marshmallows, so I'll have to order them for my s'mores that I want to make. So 18 minus 14, and when I do that, I recognize that 14 is the number farthest from 0, so I'm going to do 14 minus 8, which will give me a 6. That will give me negative 6 marshmallows. I owe people 6 marshmallows. So that's the first one. On the next one, these are also like terms. What a lot of students forget is that there is a number in front of a letter. If it's not showing, it's understood that it is a 1. So I'm going to put it in as a dotted one so you can see that there are, we'll call them animal crackers. You have 6 animal crackers and then you get 1 more because your kid brother hands it over to you. So if you have 6 animal crackers plus 1 more animal cracker, that gives you a total of 7. So you end up getting your 7 animal crackers. On the next one, we have to distinguish which ones are like. So if you're looking at the example here, there's negative y squared. So again, it's understood if there isn't a number that that's a negative 1. So I have negative y squared, and then the positive 3y squared goes with it because they both are the same thing. So y squared would be yo-yos. I don't know. It's still a label. It just because I have an exponent on it doesn't mean it's not a label. The exponent only applies to the y, so the y squared is the label. And then you do the same thing you've always done with the numbers. So you have negative 1 bad guy, so you have 1 bad guy, and then you have 3 good guys. So you're going to end up with 2 good guys, and so you've got 2y squared as your label there. Since 7 is not like, we have to just keep it, and that is as far as you can go. Since they are not like, they are not both y squareds. So the next one, we have 2 pairs of like terms. We've got the z's, and it's understood that if there is no number on the letter, you call it 1z. And then you've got the numbers that you're more comfortable with without the letters. So that would be your 5 and your negative 4. So we're going to be combining the circled items, which are the z's. So if I have 6z and I add 1 more z to it, I have a total of 7z. And then if I have 5, and there's no label on it, so it's just 5, and I subtract 4 from it, I'm left with 1 of this no label thing. So that means that they are not like because we have z terms and non-z terms, so our answer is going to be 7z plus 1. The last case, I have 3 different sets of like, and mathematicians can't help themselves but to alphabetize, so we're going to alphabetize this. I have 9 xylophones or x-ray machines. Let's do x-ray machines. I have negative 9 x-ray machines, and then I have a negative x-ray machine. So, and again, we understand that to be 1 label, so that's why we call that 1x. So how many total x-ray machines are we in the hole? Basically is what we're saying. So we're negative 10x because that's how many were in the hole. We had negative 9 and then we take 1 more away, so we're really in the hole. So that gives me our x's. Then we're going to look at our y's, and we're going to box in our y's. So I have negative 7y, and I've got a negative 2y. Keep in mind that the sign to its left belongs to the number. The y is the label. I say that they're both negative, so I have a -2 and a -7, which gives me a total of -9. So I have -9y when I deal with my y's. Last but certainly not least, I'm going to underscore the +2 and the +12. So those are the numbers that don't have letters. They are like terms because they are both constant terms, we call them. So if I have 2 and I add 12 to it, I have a total of 14 constants. So my answer is going to give me a -10x minus 9y plus 14. And that is my solution.